Okay, good. We're ready to go. We're downloading some data today. I'm trying OBS now for the recording, so I'm gonna see if the PDF scrolling goes better. So Chicago portfolio optimization D-Wave. We want to have both the article and we want to have also the Medium paper. Good. Okay, so um, or I should just download these and why is the internet so slow? It's as shitty as before. Is it just Chrome, or is it like so? Is it just Chrome or is it me? So Adobe Reader. Let's see. So what if I open the what if I open the downloads? This guy. Okay. Content preparation. What the hell? Why can't you just open the PDF? The document's being prepared. Are you kidding me? Like, how it can take... So, anyway. Initial portfolio results, August, updated. I'm looking for the... Because here, in here, they talk about 60 US assets and not 40. I think it's basically the same idea, right? I think it's the same concept, just with 60. So let's see if we can get the data. And I think so. The 60 stocks include these ones. Okay, data from Yahoo Finance. Okay, initial results. We track 5 portfolios from market close. Our 2 stock solutions, the opposite solution for the return. The CQNS and CQR portfolios that were based on the selection of portfolios chosen by the D-Wave quantum annealing computer worse than the 60 stock benchmark. For both the Chicago Quantum generalized portfolios, not optimal and selected out of 6 and 7 asset solutions, underperformed the 60 asset universes they were chosen from. One portfolio outperformed the S&P 500, while one achieved equivalent results. Hot off the prices, August 18th. While the markets have increased in the past 5 weeks by 7%, our Chicago Quantum Ratio portfolio of 6 stocks kept pace with the market, while the Chicago Quantum Net Score portfolio of 7 stocks underperformed by 1.7. However, our ideal portfolio, which had the best CQNS score out of all outperformed the market by 7%, or doubled the return. In other words, we found the goose that lays golden eggs. Our realistic interpretation is that 3 weeks of results on one portfolio selection is not enough to draw conclusions. We might have gotten lucky in the small optimal CQNS portfolio and unlucky in the more generalized solutions. We plan to expand our footprint and both evaluate more equities, broaden our search, and evaluate more equities at one time. Scale up our search. Okay, whatever. Let's. I just wanna. Okay, let's see. I think it's still as shitty as in. Why is it that it's so difficult just to scroll through just a damn PDF? I think I want to zoom in. Whatever. I think the Chrome one is good enough. So I'll just open it in Chrome. Okay, but we want to download the 60 stocks. And at least go through the what I want to do is go through the steps that are outlined. Is it in page 9? Here, download the one year of daily market data for a specific set of N assets and indices. Current as of that moment, hold the data for all experiments, calculate covariance of each asset with the market, and beta, and based on log returns. Calculate covariance terms between assets. Calculate underlying and summary values, including Sharpe P ratio and Chicago net score for an all asset portfolio. Hold all 40 assets for an equal investment amount. Let's see if we can download the data. Okay, so we have these stocks. So they say this is coming from Yahoo Finance, right? Yahoo Finance download market data. And Yahoo Finance. To forecast the future of a company or data market insight. Historical data can be downloaded as a CSV file to be used offline, which you can open with the Excel single program. The data requested is beyond the range of historical prices available through Yahoo Finance. All available data. Okay, but how do I do that? How do I do that? So okay, here. Okay, so here I can download. Okay, so you have open, high, low, close, adjusted close, volume. Do I have to download them one by one, or historical data? So I can do my portfolio maybe, right? I guess. I have to sign in. Brokers and trade, no. Watch lists. Watch lists. Personal finance. News, markets. Finance, home. CSV is an actual symbol. Now I realize. So if I go and I just search for the list, like AA, for example, right? Like, no, it went too fast. AA. So slow. Alcoa Corporation. Oh, I cannot to watch list, but I don't think I can download. Then if I add to watch list, I'm trying to. I don't want to do this 60 times. And maybe we'll do a small. At that point, I don't know if it's worth going all the way through the 60 cases and just do a small example. Like I can download the historical data here, but I don't want to do this 60 times. If I add this to a watch list, I gotta sign in. I don't want to sign in. Historical data. Historical data, and so yeah, let's say I'm not going to be rigorous with these. Okay, let's not, like, this is not, I just want to compare. Like, I don't really care about what their particular results. I want to, what I want to compare is I want to compare what does the D-Wave system give me versus what does the IBM system give me. So maybe we should pick just some of them and play with like a small example. So, okay, what can I do? So I'm gonna download a, yeah, so that's a year worth of data. Daily, right? Like they do daily, or what did they, yeah, daily market data for a specific set of N assets. So I'm gonna download these as a CSV. Yay. Okay, cool. We'll pick cap like AA, AAL, historical data. Historical data. That's so slow. Download. Then we will go with AAPL. And I'll pick maybe oh, that's Apple. And I'll pick like 2 indices. Historical data. Historical data. Yeah, I'm pretty lazy, I have to admit. I don't know. Download. And then we'll pick like, I don't know, what indices are. So here there's, they pick like GSPC and RUT, whatever these are. GS, was it PC? Yeah, oh, that's S&P 500. Okay. Historical data. What? Boom. Let's try again. Let's try again, okay? That failed. Then we'll pick something else. RUT and W5000. So RUT. Just no such index, or what's the... The Russell 2000. What's wrong with the indices? Temporarily down. Then I don't know. I'll try another one. If not, then I'll just pick 2 other assets and I can just get down with it. Oh, come on. You're kidding me. Then I'll just pick like, I don't know. Let's pick What's the one for Tesla? Tesla. Quote. What's wrong? Is it that, like, I don't know. Maybe let's just finance.yahoo.com. Can I not download these from, like, maybe there's Google data I can download as well. So what if I do again try Tesla TSLA, and so oh, now it works. Yeah, maybe I think it was okay. So I'll try actually to get two indices as well. And so the other one was the S&P 500, right? We tried. That's the one that broke the whole thing, though. Damn it, I hope that I'm capturing the audio from the microphone here. I hope so. Yeah, I think that should be download. So now I've got an index, and now I'll go for which other one do we pick? Do we pick what was another one from here? Let's go with this one. Let's go with this one. I'm I'm extremely worried that I'm not capturing the audio. I just hate myself for this, and I don't know if I can stop recording and then glue things together. I'll probably do that just to make sure that I'm actually capturing the audio. Let me just download this one, and then we'll. Although I have 5 already, it's fine. We'll just get another one, 6, just to have 2 indices in there. So I'll stop the recording now for a second and check whether I actually am getting the audio, and then glue things together. Okay, I'm testing, so it seems to work from an audio perspective, and I'm hoping, now I'm changing, I realize I can change some of the encoding stuff and get a lower CPU usage, which makes the scrolling actually better. Also from a PDF perspective, I hope. So I'm getting CPU of 11% right now, 7%. It's not that bad, I guess. Looks fine with web pages. I'm at 16%, 17% again, 6%. We'll see how this goes. Okay, so we've got these now. So how do I even open that? So I have a CSV file with the market data, daily basis for a year. I guess I should basically calculate. Yeah, so it's a CSV file. So we've got the date, open, high, low, close, blah 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 blah. So it's a date, it's an open, it's a high, it's a low. Now, how do I calculate what I want to calculate? Which basically is I want to calculate the Summary values, the covariance of each asset with the market, and beta, and then three based on log returns. How do I even approach these? What is these? Beta. What is beta? It's a measure of volatility. Oh, that is actually how beta works. Covariance, the return on individual stock, the return on the overall market. Covariance, how changes in a stock's returns are related to changes in the market's return variance. No, sorry, that kind of took me away from the actual paper. So, and beta 3 based on log returns. Calculate covariance terms between assets. Calculate the underlying and summary values, including Sharpe ratio and Chicago quantity score for an all asset portfolio. Hold all 40 assets for an equal investment amount. Okay. First I should open probably a Jupyter notebook. So Anaconda, PowerShell. So these, right? And so we're gonna go to workspace, to my quantum workspace, if that opens, if that starts. Hello. There you go. So ls, so cd workspace, right? We're going to workspace, and here we're kind of gonna probably make a we'll call this portfolio optimization. And we'll just go inside in here, and here Jupyter notebook. Was it like this? I forgot how to open a Jupyter notebook. Come on, you can. You can. Okay, we're good. So we're gonna create a. I gotta work on the setup. I feel like I mean, it's not that I have a beast of a machine, but like things go slow while I record. That's not. Okay, I have absolutely no idea how to read CSV data. So first of all, we should work on these, I guess. Python 3, read CSV data. Python 3, or I guess NPM, covariance, Numpy covariance. So I guess Numpy read CSV data. How does it work? Numpy. I wonder if there's a dark way to import the contents of a CSV file into a record array much in the way that R is. So you can use NumPy's gen from txt method to do so by setting the delimiter arc to a comma. So from that, so let's first of all, what we should do is we should take this data from the downloads folder, okay, and move it all to the workspace, right? So should have a shortcut for this that searches in the workspace. And now we have here, and we'll create another folder called data, and we'll just paste the whole thing here. Okay, so I'll get these in here, and now do so my data, and so we'll just basically do like data, and it's like AA, right? I think. Bit of comma, print my data. Okay, so there is something being printed in here. It says not a number. Can I open the file first of all? So let's go back. Quick access. No, I should pin this. Instead of just going all the way to users and workspace and portfolio optimization, can I just pin the workspace somewhere in the quick access bar? Yeah, pin to quick access. Nice. Workspace. Awesome. Portfolio optimization, data. Let's open AA. See what it looks like in Excel. So I probably want to load all this stuff into different arrays and then kind of calculate the calculate what the paper is telling me to calculate, right? So, oh yeah, so the first is basically, yeah, the first is the date, so it's not a number. And then you have like the 17.84, 18.23. Okay, so how do I print this data in a nice way? Python. Okay, now values. Okay, header none. This is a pandas data frame allowing many useful data manipulation functions which are not directly available with Numpy records. Okay, so this is another way to do that. D-type. Then Numpy. Strings and names. D-type none. What if I give it D-type none? What's it gonna do? Okay, now actually tries to guess the stuff. Reading Unicode strings without a specific encoding argument is deprecated. Set encoding used now for the system default. Set the encoding. So I have to set the encoding. So set encoding. What am I doing? What? Sorry. Coding. Okay, so I will just encoding non. Okay, date open high, whatever. So I can ignore but I think I can ignore. How can I ignore the headers? So ignore headers and select columns. I'm not interested in the date, I guess. Extract columns. Skip. Okay, so skip header. The file you're reading in a generator that generates lines, skipping the first n columns. If your numbers are space separated, that's something like and I probably want the different columns, right? Like, let's bring the lines into columns. So once the file is defined and open for reading, gen from txt splits each non-empty line into a sequence of strings. Empty or comment lines are just skipped. The delimiter word is used to define how the splitting should take place. Quite often a single character marks the separation between the columns. There's a comma separated files with comma or semicolon delimiter. Another common separator is the tab character. By default, when a line is decomposed into series of strings, individual entries are not stripped off leading nor trailing. Comments, skipping lines and choosing columns. The presence of a header in the file can hinder data processing. Skip header. Optional argument must be an integer which corresponds to the number of lines to skip at the beginning of the file. Okay, the use calls. Okay, so there's a use calls argument. Okay, so if we want to import only the first and the last columns, we can use calls 0 minus 1. Okay, use calls and skip header, right? Skip header. So we're going to basically say skip header 1 use calls was it like with the brackets like these? Use calls, say just one, we just want first. Okay, so that's the, yeah, that's at the date. These are the dates. Okay, so, okay, cool. So here we have like, all the, okay, cool. So that's the first data. So the first part. So we, what I want to have is, so we have open, high, low, close. So I don't know if I should have them all in separate arrays or I should import them all as a matrix, or I just care about the close. I think I just care about the closing value, right? Probably. I think let's just keep the close, which is basically 0, 1, 2, 3, the fourth value. So this is just a close, and then we'll just say fourth value, and there you go. And so all we want to do is we just want to get, so we just want to basically, what are the files that we have? We have AAL, AAPL, right? So AAL is like probably it's going to be easier if I go and say data source is basically an array, and then I'll just give it the name, and so it's going to be AA. So assets, I'm going to call these assets AA, AL, AAPL. What else do we have? TSLA, TSLA. What else we have? I'm gonna remove the character here in the file name just because I think it bothers me. I just want to avoid these leading into any problems. So we have W 5000, and we have, what else do we have? GSPC. So we have these assets, and then so we're basically what we want to do is we want to have as data. So this will just be an object. You know what? That's what I would do. And so what I will do is this is just like an empty array, right? So and I wanna basically I'll make a function. Or I'll just iterate over the asset. So I'll just basically say asset data for each. Can I just I'm such a noob with these Python for each. I gotta look this up every time. Every time. For effing pets. For petting pets. Okay. For I in wrench. It's a dictionary, so for key value in dictionary items, okay, so for key value, Python 3 iterate the dictionary. Real Python. Just please for key in. Okay. Just like that. Okay. So for asset in as data. So what we'll do is basically, you know, data, or basically, we'll just basically say asset data, asset equals this, and we'll just basically asset name. For asset name in as data, or asset key, I'll call it. We append the asset key here, and print as data. Invalid syntax. Why? It's a semicolon. Okay, so we got the AA. Where's the, okay, so W500. Okay, cool. So we have these now. We have everything in a dictionary. I don't know if it's the best way to represent these. Maybe I should do a matrix. Who knows? And now the next thing that we want to do is we want to calculate. So where were we? Covariance of each asset with the market. So how do I do this? Covariance. And better based on log returns. Covariance between assets, this should be probably easy. Covariance with the market. How do I do that? So Numpy Covariance. So let's see what now Numpy has to offer. Passing Numpy function. When I pass it to one-dimensional arrays, I get a 2x2 matrix of results. I don't know what to do with that. I'm not great at statistics, but I believe covariance in such situation should be a single number. When A and B are one-dimensional sequences, is equivalent to okay, the matrix returns AA, AB, BA, and BB. Okay. So I should probably get stuff into matrices because I guess I'm what is the best way to construct these? So it's useful for what I'm trying to do afterwards, right? Because what do we want to do with the covariances? We want to build a matrix and do I have a cubo for each portfolio size? And we're aiming at doing a portfolio size of 2, for example. Thinking what is the best way, because it feels like I don't know how is this going to be used later on, and so the covariance of each asset with the market, these I could do, okay, but how do I do this? So this is the covariance of a one-dimensional thing versus like what, a it's got like multi, because then it's just a covariance of one asset against many assets. And how do I do that? So Numpy, come on. Estimate a covariance matrix given data and weights. So covariance indicates the level to which two variables vary together. If we examine n-dimensional samples, then the covariance matrix element is the covariance of xi and j, xi and xj. The element cii is the variance of xi. So that's what we just read about the matrix. So M is an array like 1 or 2 dimensional array containing multiple variables and observations. Each row of M represents a variable and each column a single observation. 1D or 2D array. An additional set of variables and observations, Y has the same form as that of M. That's my point. Like, how do I do the covariance with the market? Covariance of each asset with the market. I guess there should be. Is a market like my like set of assets? Is that what this means? Sorry, I just went not what I wanted to go. I wanted to go back up here. I hate this. 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 Slow scrolling. So how to calculate covariance of an asset against the market? Covariance. Covariance. I want to calculate the covariance of an asset and the market. So how do I do this? And beta. Oh, okay, so entire market. It says equal times represents the slope of line. Beta coefficient is the covariance of the return on an individual stock and the return on the overall market. And how do you calculate the variance of the market? Beta values. Perspective, however, financial markets are prone to large surprises, and returns are always normally distributed. Therefore, what a stock's beta might predict about a stock's future movement isn't always true. Like, are we just doing the averages? Will we just do the average or the mean or something, and then do the covariance between like these? I guess. Yeah, I guess that's what I'm gonna probably go for. I'm such a noob with all these, right? So what I want to do is I want to calculate the mean across all these vectors or something like that. Sort of per day, right? And then calculate the covariance of each asset against these asset data. So what, like market data or market summary, right? And then yeah, I think it's better. So how do I do this? How can I do this? I have, so this should probably turn this into a matrix, and then so numpy mean array. So how do I do this? I guess I want to do our array is, so I want these applying median. No, I want these. Okay, so I have an array of all these things, right? Okay, so I can and then I can apply mean on a particular axis. So I can say NP array. So I can go and say, why is it going so slow? So I can go and say asset. So this is assets data, or asset matrix, right? And then this will just be an NP array. And then I'll just say asset data AA, right? AAL, AAPL, TSLA, 5,000, GSPC. Okay, and so NP array. And so now I want to do kind of the market summary would be that I say which is x is 0. I think the x is 0 is these. We'll see, which is what we want. Yes, so x is 0. So NP mean A, x is 0. X is 0. And then, you know what? These I should do in another cell, just in case. Here we have everything ready. And now I go and I do these, and I want to print market summary. NP is not defined. Yeah. How do I import numpy? I'm so bad at these. I was just not born for programming, I think, or for remembering those constructs or the lines. It's not defined. Of course it's not defined. It's asset matrix, what we want to do. Okay, so now we have... doesn't seem right, though. So what is the length of this? How do I print? Oh, it's 254, and what is the print length of these? Oh, that makes sense. Okay, cool. So we've got the market summary, and then now we can calculate the covariance, right? Between each asset in the market. So I'm going to create another variable like these. So I guess what we want to have is market covariance. So this will. What is the null? Is it like isn't that like null correct, or Python? Does Python have null values? None. Okay. None. 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 And so we trade across these, and then we say basically market covariance as a key is basically NP. It's actually going to be matrix NP covariance of what? Of asset data, asset key, and market. How did I call it? This thing here, market summary. Does this make sense? Market summary, and then print market covariance, for example, of like AA. Okay. Okay, since we got something, might be wrong, but at least we got something. It's not breaking. Cool. Okay. Okay, cool. So we have that. Portfolio stuff. Optimization. So we've got the covariance. And now what we want to do is we want to go and do the covariance between assets, and the beta also based on log returns. Did the same mistake. So how are we going? Yeah, cool. So now we have the covariance of an asset and the market, and then the variance of the market. So that's the beta coefficient. So what is the variance of the market? Numpy variance. So basically, okay. So if I do print NP var variance of like of market summary, okay, I get a number. If I do then So what I should do is I should do basically the covariance of each element divided by these. So I kind of have to do the covariance is in the market covariance object. So we're going to do another thing like that, right? And we're going to do asset beta, and so for each asset key in asset beta, asset key equals basically the market covariance the market covariance asset key for asset key. So market covariance of asset key divided by NP var of market summary. I have no idea what what I'm doing is correct. Asset beta, print asset beta. Okay. No. Yeah. Okay. So there's basically. But why is it an array? Oh yeah. Sorry. So the covariance is an array, and I want the first I want the 0, 1, right? So I want this is what I want, right? Yeah. So we have for each asset we have the asset beta. Let's save these. Okay. So where are we right now? I mean, you know, if it's a little bit wrong, we can correct it later. It's all fine. I just wanted to at least go through the preliminaries of these today. So we have the variance of each asset with the market. We have beta. I haven't done it based on log returns. Maybe I should do these, but I have to understand. I don't really know if this is already what it is. Or is it like beta coefficient? Is it that there's like a log returns? Talking about the return, I have no idea what's like the return of an asset. Is it the close value? I'm just using the close values. Maybe it's not. We can change that. That shouldn't be a problem. As long as we get like the actual calculations right, then we can change the data that we use. That's not a problem. Then okay, let's try to go at least get through. How much time do we have left? Okay, kind of getting late actually. So let's do the covariance terms between assets. Okay, so here I need to specify then need to do a double loop, right? Like the covariance between assets. So we will do basically what we'll do is we'll do something like that, but basically have sort of an empty dictionary, and we'll call this like asset covariance. And so what we'll do is we'll go asset key, asset data, right? This is correct. Asset key, asset data. And then we'll do a nested loop in here. Asset key B, asset key A in asset data. And what we'll do is we'll first do can I just say asset key A plus, so we'll just concatenate it this way, asset key B, and so here we'll just calculate the covariance. So we'll just do NP covariance between asset data, asset key A, and asset data, asset key B. And then we'll just do print asset cov and see what we have. Yeah, okay. So we're calculating the covariance between each of these things. We're doing probably too many, because we'll do like AA underscore AAL and then also AAL underscore AA here. So this is kind of a duplicate in this, from this perspective. No, maybe not a duplicate, but like, okay, so we've got these covariances between the different assets. So there you go. And now kind of, I think I'll leave it here. So the next step will be to actually get into the actual summary values, the Sharpe ratio and the Chicago quantum net score for an all asset portfolio. Hold all 40 assets for an equal investment account amount. So we've done points 1, 2, and 3. We're gonna go through point 4 in the next video, and maybe we'll touch point 5. Again, I might have gotten this wrong in terms of the data that I'm using, but like, I don't know, we'll adapt, okay? So I'm a noob in everything. Quantum computing, I'm a noob in Python programming, I'm a noob in NumPy and statistics. So we're all learning here, and I hope you're learning with me. Cool. We're just like hacking a little bit together. Perfect. I hope you enjoyed the video. Stay tuned for the next one in the series, and see you next, I guess, tomorrow, in 2 days. I don't know. We'll see. Bye-bye.